Hello, lecture laners. Now, we've had a look at how trigonometric functions are used to solve triangle problems. Well, how do we graph them? Let's find out. So today we're going to be looking at the sine, cos, and tan graphs and how to graph different iterations or variations of these graphs. So to start with, let's look at our basic graphs. So y equals sine x. What this graph looks like is a wave that starts at 0, 0 and moves through one up and down motion between 0 and 2 pi. Now don't be confused, this graph technically goes from negative infinity to infinity. However, most questions will get you to work within the range of 0 and 2 pi. However, they could ask for negative pi to pi or any range they like. However, typically we work between 0 and 2 pi. So that's what we're going to do today. This graph extends from y equals 1 to y equals negative 1. And our points of interest are where it passes through the x-axis and also the maximum and minima. So 0, 0, this maximum occurs at pi on 2, 1. Another x-intercept at pi 0. 3 pi on 2, negative 1 is our minima, and we finish at 2 pi 0. For our cos function, the graph appears to be very similar to sine, except at this time it starts at y equals 1, going from 0 to 2 pi. The lower limit of the range is negative 1 as it is in sine, and the upper limit is 1. Our points of interest, we have a maximum at 0, 1, an intercept at pi on 2, 0, a minimum at pi negative 1, an intercept at 3 pi on 2, 0, and a maximum at 2 pi 1. What you'll notice is that everything occurs at intervals of pi on 2. Lastly, our y equals tan x graph. Our y equals tan x graph is unique in that it has asymptotes. An asymptote being an imaginary line which our graph approaches but never touches. So what tan looks like is it starts off at 0, 0 and arcs up like an x cubed graph. However, there's an asymptote at x equals pi on 2. The tan graph will then make an x cubed like shape before hitting another asymptote at 3 pi on 2. And then continue up again to intercept at 2 pi. So the only other point of interest is this intercept here, which is at pi 0. So these s's will continue on to infinity. Now, with an idea of how these base graphs work, we can start to look at how to graph more complex trigonometric functions. We can put different coefficients in different places, and therefore solve questions with a multitude of different variability and number combinations. There are 4 parts to any trigonometric function which will change how we graph it. Let's look at a sine graph to understand how this works. So we have a number that can change out the front of our function. We have a number that precedes our x. We can also add a number to our x, and then we can add a number at the very end. Now this first number we call the amplitude. This affects the range in which the function operates by either making it go higher or it can make it more flat. The B I call the wave number. This represents how many waves fit in between 0 and 2 pi. For example, if the wave number was 4, I would know that 4 waves occur between 0 and 2 pi. C I call the phase shift. This moves the graph either left or right, and I'll show you how we figure that out later on. And finally, the last shift is vertical shift. And this moves the graph either up or down. Let's look at some examples. Let's say I've been asked to graph 3 sine 4x between 0 and 2 pi. Well, the first thing I look for is D, which is the vertical shift, and it's the number that comes at the end of our trigonometric function. As you can see, it's equal to 0. It doesn't exist. So therefore, there's no vertical shift of our function. Next, I look at A, which is our amplitude. And as you can see, the amplitude is 3. What this means is that my graph, instead of being between 1 and -1, as it is in our base trigonometric function, it's now between 3 and -3. Next, I look at C, which is phase shift. And luckily for us, there is no phase shift in this function. And lastly, I look at the wave number, which is equal to 4. So what that tells me is that this is going to have 4 waves. 3, 4, between 0 and 2 pi. So what that means is that our halfway point, that's pi. Here it's pi on 2. Here it's 3 pi on 2. And that would be all the relevant working you'd require to show that you've graphed this correctly. Let's look at another one. So again, I'm going to go through D, A, C, B. Now there's no D, so we can skip the vertical shift. Next comes A. So we've got a -2. So negative means we're going to be flipping this across the x-axis. So instead of having our typical shapes which point up towards the top right, we're now going to have shapes which bend towards the bottom right. And it stretches by a factor of 2. However, with tan, it's not as important as the range extends from infinity to -infinity. Next comes C. So how do we work out how much a graph has moved to the left or to the right? Well, how I complete this is I make whatever's inside the brackets equal to 0. Solving for x, I'll find out that x is equal to -pi on 4. What this number represents is how far the graph has shifted to the right. Now in this case, it's -pi on 4, so the graph has shifted to the left. Therefore, we're going to have a graph that looks like this. Because the graph would normally look like that. But because we've had to shift it to the left, we cut off everything that's not between 0 and 2 pi. Now, if we want to find out our intercept on the y-axis, we would sub in x equals 0 and solve for -2 tan pi on 4. In this case, it'll be -2. The asymptotes will now be pi on 4 less than they were before. So this one was pi on 2. Now it's pi on 4. This one was 3 pi on 2. So now it's 5 pi on 4. And this is 2 pi -2. And this occurs at 3 pi on 4. 7 pi on 4. The last thing is to check our wave number, which in this case was 1. Therefore, our final answer is this graph. We'll do one more question. Let's make it difficult and use all our skills. So the first thing to notice is our D. Our D is +1, which means the graph is shifted up 1. So the middle of the graph is now going to exist at y equals 1. Next, we look at the amplitude. And as it's 12, it means it's going to extend up 12 and down 12. So our upper limit will be 13 and our lower limit will be -11. Solving for 2x minus pi on 2 will help us with our phase shift. So therefore, x is going to equal pi on 4. So therefore, this graph has been shifted to the right by pi on 4. So if this is shifted right by pi on 4, that means that our normal cos graph would start at pi on 4. Now we need to find the y-intercept, so we make x equals 0. And solving for 12 cos negative pi on 2 plus 1, we will get 1. So therefore, let's draw our first cos. And lastly, our wave number is 2, so therefore there must be 2 complete waves. We can label the minima and maxima if you'd like. However, that's all the steps we must follow. And that's how you graph trigonometric functions. Thanks for watching. Hope you enjoyed. Please leave a like, comment, and subscribe. We'll see you in the next video.